class. We're revolving. This graph right here is the aqua color line. Y equals 0 is the x-axis. X equals 2, y equals 3 are the red lines. This is the shaded region we create that's going to be revolved around the y-axis right here. Now, how did I get the 5 here? How did I know it crossed at 5 right here? Well, all I did is at 2, this is 2, this is 3. Can I just plug 2 into here? You get 5. And how do I know it hit right here? Well, then I put 3 into the function and get 0. Now, if I'm revolving it around this side, what you got to realize is you have segments that look like this. When you're revolving around that, your segments are sideways, or this direction. And you're also going to get a segment, you can get the segment that goes straight across, and you're going to be revolving them, okay, around the y-axis. Now, what you'll notice is this little shaded region, when you revolve, it's going to be hollow. So right away, the volume is equal to pi. All right, we're going to think about our interval in a second, but we have an outer minus an inner. And why is it dy? Because aren't these lines going to be added up along the y-axis? Now, for our interval, well, isn't our interval starting at 0? But how high is the interval going? Isn't it only going to right here? Is it going all the way to 9? No, because doesn't this area stop at 5? So we look right here and our area stops at 5. So we're going only from 0 to 5. That's pretty important, easy to mess up. Next, I want my outer, this is my, maybe I should write this. You have your outer and your inner. My outer radius. My outer radius would be from here to here. Now if I want my outer radius, isn't that simply going to be this one? Is it simply from here to here? Is that the y equals 9 minus x squared? Here's the problem. Isn't it in dy form? So do I going to change this? I got to change it to be, if I take y equals 9 minus x squared, I got to solve that for x. So what we end up with is x squared equals 9 minus y. Move the x squared over, move the y over. Square root, we get x equals plus or minus the square root of 9 minus y. Now, do we care about the minus? Look at the graph. Isn't the minus going to be over here? So can I ignore the minus? Okay, so I'm going to focus on the positive one. Okay. So, our equation is going to be square root 9 minus y. So, again, going back to this, wasn't the outer length just the square root of 9 minus y? That was my outer length. From here to here is the square root of 9 minus y. Now the inner length. What's the inner length? Isn't it just 2? And is it always 2? This one actually we could do pretty easily probably. Put the pi out front. Volume equals 0 to 5. When you square a square root, doesn't that just become 9 minus y? And then 2 squared is 4. Yeah, let's finish this one. This one looks doable. That gives us, it looks like pi 0 to 5, what did that be? 5 minus y dy. So that's pi, and the integral of 5 is 5y. The integral of y is y squared over 2. And our interval is from 0 to 5. If we finish this off, take it back over to here, boom. Looks like we have pi. that looks like it's going to be a 25 minus 25 over 2 minus 0. Because when you plug in 0 to here. So it looks like we have pi, and we multiply top and bottom by 2. Don't you get 50 over 2? But isn't it just going to be 25 over 2? So the volume equals 25 pi over 2.